Thomas Kochen, former NASA science director, commented on the launch of the James Webb Space Telescope, JWST, stating that James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. What began hopefully turned into a dilemma. James Webb shocked scientists with the crisis now getting worse. Will a new discovery of the James Webb Telescope and the debate in physics, the discussions about old theories, and who is right or wrong indeed be coming to a temporary end? But what exactly does this mean? Have scientists really unraveled the mystery surrounding James Webb's impossible discoveries? Or are we just being stalled with flimsy explanations? James Webb was supposed to bring solutions, but instead, the $11 billion project plunged cosmology into a major crisis. All parts of natural science associated with space are currently experiencing a shakeup of the kind we last saw in the Middle Ages with the shift to the heliocentric view of the world. Now we may have to recognize that the foundations of our modern physics are also flawed, and that we have not come close to understanding what our cosmos really is. But how is this possible? Today's astrophysics, or in other words, the science of the physical quantities and relationships in the cosmos, is based on the basic rules of physics, which essentially go back to researchers of antiquity, the Middle Ages, and in particular to Sir Isaac Newton. The first observations of mechanics and dynamics were made in antiquity. Quantities and forces were described for the first time, and later Newton discovered gravity, which is so important for astrophysics. We built our scientific observation of the universe on these foundations. We transferred the quantities and forces that were valid and observable on Earth to the universe, and this produced some consistent results. But then the space we can see got bigger and bigger, and at a certain point our quantities no longer fit to describe what we see. This crisis began with the problem. The different methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble tension, while the Hubble constant indicates the expansion rate of the universe. In the summer of 2022, Webb discovered so many old and highly developed galaxies in space that doubts arose as to how the age of the universe was determined. Our cosmos can hardly be 13.8 billion years old if, thanks to Webb, we see galaxies that were already well-developed 200 to 300 million years after the Big Bang. According to the calculations of our physics, galaxies need billions of years to grow. In the case of the galaxies discovered by Webb, this would even mean that the time of their formation was before the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since and has undergone a slow process of evolution of matter, cannot be correct. We are at a crossroads. Either we are making a mistake if we think that our earthly physics can be applied to the entire universe, or we have so far only deciphered a small part of the physics that really exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics that exist in the cosmos should also be found on Earth, but perhaps we have overlooked forces and dimensions on our planet that we are now noticing in the cosmos. Webb breaks all records. It's fantastic. This telescope can pick up extremely weak light signals. Webb's 18 honeycomb-shaped mirrors effortlessly detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these faint traces of light visible for the first time. Thanks to the new revolutionary technology, we saw the light from the most distant galaxies that formed shortly after the Big Bang for the first time in the summer of 2022. These galaxies were a sensation and at the same time a bitter disappointment. Instead of baby galaxies, Webb shows perfectly developed galaxies that appear to be several billion years old. But with an age of 13.5 or 13.6 billion years, this can never be the case. These days, scientists sometimes say that the objects in the images aren't impossible or not real. But Webb can only show us the truth. Science must now admit that it has probably been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see here is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with the new truths. Some of the old traditionalists who don't want to look at the new truths in the face vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, it also took many years before the Church was finally willing to admit that the Earth was not the center of the universe, even though there were suddenly masses of evidence from astronomers all over Europe. So not much seems to have changed, and although we consider ourselves much more modern today, we have a similar scenario. Researchers who proclaim something new may no longer end up in prison like Galileo Galilei, but the quarrels between researchers and the hostility towards new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tells a different story. Perhaps your mind would also rebel against this at first, and it would take a while before you could accept the new truth. As everywhere, there are some who are quicker to adapt and others who take longer. Many open-minded and young scientists are enthusiastic about Webb's discoveries. Rohan Naidu, the discoverer of the Glass Z13 galaxy, and Stephanie Galini, who discovered Mars Galaxy, belong to this open-minded generation of researchers. They look at Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasize several times in interviews that we simply cannot know what will happen in astrophysics. At this moment, we have to wait for further measurement results, studies, and of course Webb's latest images. Was it Hubble's fault? Let's take a look at the dilemma. One of the great debates in modern cosmology concerns the Hubble constant. This is the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us. From this, he concluded that the universe is expanding. The idea was later expanded upon, and the Belgian astronomer Georges Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we already know from alternative methods that the movement of galaxies can also be explained differently, and these approaches also provide a coherent picture in their entirety. However, they were ignored for a long time because the old theories were considered more probable. But the more we see of the universe, the more discrepancies emerge. This didn't just start with Webb. Even 20 years ago, there were regions in space where the expansion was behaving differently. It was as if these regions were sometimes faster and sometimes slower, or perhaps denser or emptier. This led to speculation that there may have been several starting points or that our universe is even permanently fed by several sources, which do not necessarily all have to have had a beginning at the same time or at all. Alternative ideas about the shape, nature, and age of the universe emerged once again, but researchers continued to cling to the old theories of the Big Bang and expansion. This was possibly a mistake. We have already briefly learned about the Hubble tension. In short, it shows clear differences in distance measurements in the universe depending on which fixed points we use as measurement constants. Now scientists hope that the Webb Telescope, as its mission progresses, will be able to resolve this tension by making precise measurements of the distances and redshifts of galaxies. The potential correction of errors in previous measurement methods not only represents a crucial turning point but also holds the promise of ushering in a transformative paradigm shift, propelling us into a new epoch of advanced physics that penetrates the very fabric of cosmic reality. This monumental achievement stands as a testament to the unwavering dedication and tireless perseverance of generations of researchers who have devoted their lives to unraveling the enigmatic mysteries of the universe, tirelessly pushing the boundaries of human knowledge ever further in their quest for truth and understanding. In their relentless pursuit of knowledge, these intrepid explorers have not only expanded the horizons of our understanding of the cosmos, but have also enriched our collective consciousness, igniting a sense of wonder and awe at the vastness and intricacy of the cosmos that surrounds us. As we stand at the precipice of this new frontier, poised on the threshold of discovery, it is incumbent upon us to approach each new revelation with open minds and open hearts, embracing the potential of even the most unfamiliar or shocking findings to reshape our understanding of the universe in profound and unexpected ways. Indeed, the emergence of new theories and alternative explanations heralds the dawn of a new era in scientific inquiry, where entrenched paradigms are challenged and bold new ideas beckon us forward into uncharted territories of knowledge and exploration. At this pivotal juncture in history, we find ourselves on the cusp of a profound scientific revolution, where the investigation of the oldest points of light in the universe holds the tantalizing promise of unlocking the deepest truths about the nature of existence itself. With the advent of cutting-edge technologies such as the James Webb Space Telescope, we are poised to embark on an unprecedented journey of discovery, delving ever deeper into the cosmic tapestry to unravel the mysteries of accretion disks, probe the enigmatic realms of supermassive black holes, and peel back the layers of cosmic phenomena that shape the very fabric of our universe. Yet, as we chart this bold course into the unknown, we must also proceed with caution, mindful of the complexities and uncertainties that lie ahead. For every new revelation brings with it a host of new questions and challenges, inviting us to venture further into the abyss of the unknown and confront the mysteries that have eluded us thus far. In the grand tapestry of cosmic evolution, each new discovery is a thread woven into the intricate fabric of human knowledge, enriching our understanding of the universe and our place within it. As we embark on this exhilarating journey of discovery, let us not only celebrate the triumphs of science, but also embrace the uncertainties and challenges that lie ahead. For it is through adversity that we grow and evolve, both as individuals and as a species, forging a path toward a brighter and more enlightened future for all of humanity. We would then have to revisit our cosmology and find out whether black holes played a much more important role in the discovery of the universe than previously thought. One theory that points to this comes from the British scientist Roger Penrose, who believes that the universe is constantly recreating itself in cycles, and that black holes could somehow survive such transitions as gigantic stores of information. Penrose published this theory long before Webb was launched, but although the Briton is a renowned researcher, his work was not accepted. That is now changing. Webb's mission has only just begun. We already have a second deep image. When we have the discovery of a very old structure that is so large that it also does not fit into the young universe, this evidence is growing in the vast expanse of the cosmos where galaxies swirl and stars dance in the cosmic ballet. Humanity has embarked on a journey of discovery unlike any other with the launch of the James Webb Space Telescope. As we stand on the precipice of a new era in astronomy, the anticipation of what Webb will reveal fills us with excitement and wonder. It is not merely a tool for peering into the depths of the young universe. Rather, it is a beacon of exploration, tirelessly charting the celestial landscape, unveiling the secrets of distant worlds, and shedding light on the mysteries that have captivated human imagination for centuries. The scope of Webb's mission extends far beyond the boundaries of our own solar system. With its unparalleled capabilities, it delves into the realms of exoplanets, probing the atmospheres of alien worlds and searching for signs of habitability, offering tantalizing glimpses into the possibility of life beyond our own blue planet. Moreover, Webb's keen eye is turned inward, illuminating the intricacies of our solar system, from the icy moons of Jupiter to the rocky terrain of Mars, with unprecedented clarity and detail. But Webb's reach extends even further, stretching across the vast expanse of space to capture the grandeur of the most massive and beautiful structures in the cosmos. From the swirling arms of distant galaxies to the luminous glow of nebulae, each image captured by Webb tells a story of cosmic evolution, of stars being born and galaxies colliding in a cosmic dance that spans billions of years. Yet, Webb is not merely a passive observer. It is a catalyst for discovery, a tool that propels us forward in our quest to unravel the mysteries of the universe. With each observation, Webb adds another piece to the cosmic puzzle, enriching our understanding of the fundamental forces that govern the cosmos. Even data collected from seemingly distant realms hold the potential to offer invaluable insights into the underlying structure of the universe, providing clues about the nature of dark matter, the origins of cosmic rays, and the fundamental laws that govern the behavior of matter and energy on the largest scales. In our pursuit of knowledge, we are driven by a desire to uncover the underlying framework that governs the cosmos, a cosmic matrix that holds the key to understanding the universe in all its complexity. Webb's revolutionary capabilities propel us forward in this quest, opening new avenues of exploration and sparking fervent debates among scholars as we grapple with the implications of its findings. And though we may find ourselves amidst a period of uncertainty and heated discourse, we remain steadfast in our belief that this crisis will ultimately propel us closer to the truth. So as we eagerly await the next revelations brought forth by Webb, let us embrace this journey with optimism and curiosity, knowing that with each new discovery, we inch closer to unlocking the secrets of the cosmos. To stay updated on this thrilling expedition of discovery, don't forget to click the subscribe button now. Many more captivating videos are sure to follow, each offering a glimpse into the wondrous mysteries of our universe and the groundbreaking discoveries that await us.